welcome to Desk LADYADA.
Hey everybody, happy Hanukkah, happy Sunday. It's, oh cool, my green laughing squid shirt is black.
That's right.
It looks really good. Welcome to another Desk of LADYADA. It's me, LADYADA. As always, we're broadcasting at LADYADA o'clock, which is kind of late on a Sunday, sometimes between 8 and 10. And we had an exciting weekend, relaxed, rested, got some prototype PCBs. We're all ready to show off all the cool electronics we've been working on all week here at my desk.
All right, what do you want to show off first?
Well, do we have any news or updates we want to give people?
News and updates, our shows are all on regular schedule this week.
Yeah.
Next week we'll have a different schedule, but Ask an Engineer, Show and Tell, Desk of LADYADA, all those things will be happening. We also have our 20% off sale, so you can secure your account.
Two-factor.
By doing that, just verify your email address and secure your account with two-factor, and you get a 20% off coupon in the Adafruit store. We're going to run that probably until next week. So
Yes.
Do it now, though, because we're going to run out of stuff.
We are running out of stuff, although we're trying to get more stuff made next week, so
Yeah.
the last push before the holidays. Okay, so yeah, we got some prototype PCBs. We sent out a panel about a week ago. It takes about a week and a half for prototype PCBs to get made and get back to us. So let's go to the overhead and we can check out what we have received.
Yeah, and Scott's in the chat. Scott will be streaming Thursday, not Friday.
Okay, so first off, remember like a week and a half ago, we showed off this Cobbler 400. This plugs into the back of a Raspberry Pi 400 and lets you put like a bonnet or a display, or it doesn't have to be a display. It can be anything. We showed it off with a display, but it can be a sensor hat or an I2S speaker display or whatever, or audio input and output. We also have so we routed this out on the other mill because it was simple enough design. We just wanted to mechanically see, does it work. And the hardest part of this was actually like figuring out like the way the pins go, because it's like flipped, but it's like reverse flipped. But anyways, this came out good, and so we were ready to turn it into like a more formal prototype. So we ordered PCBs, and I made a couple changes. One, I shifted, the board was to the left on this side, and on this one I shifted it to the right because there's actually some ports on the left side here, and I was like, I didn't want this to possibly block them. So I instead kind of like yoinked it over to the right. And then there's this space underneath because the bonnet's going to plug in on top. And so I put some Stemma connectors. It's Stemma Sunday. I always try to represent the Stemma action. So 2 3-pin Stemma connectors. And those are good for like servos and NeoPixels, relays, stuff like that. And then Stemma QT for I2C. And then you'll note I have this kind of mixed surface mount or through-hole connector header. And here are all the pins on the back. So I basically took these, instead of being on the front, they're now on the back, which I kind of like. I prefer that style. But the surface mount / through hole means I can either do selective solder, or I can surface mount, pick and place the connectors. These connectors come, you can see these are surface mount style. They kind of bend out. They've got these little splay legs. These are more expensive than plain through hole headers because they've got that bend. But they are easier to manufacture, right? You don't have to have a second process, the selective soldering process. We can just pick and place them all in one step. And so I like to kind of give myself the option of either. So depending on how my design goes, if I can have the connectors or parts in stock in time, I can go with either. These are less mechanically strong, but again, they're not that much less mechanically strong, and they're much less difficult to process in our pick and place line. And then we also have the full hat version. So this is the same exact setup basically, but you see I just stretched out this part so it can fit a full Raspberry Pi hat. So these came in. I'm going to put these together and try them out. And one of the things that a lot of people asked about was like, well, when you have it plugged into the Pi on the back of the 400, especially if there's a display, you'd want it to be tilted a little bit. And is it possible to get headers that are not right angle? Like this one is right angle. Like this is the header and this is the PCB, and it's a right angle. And can you have it be tilted so that the display is at a little bit of an angle? It's a little bit more visible. And that actually isn't a connector that's available off the shelf. The connectors for headers like this 2x20 socket or plug headers, they only come basically in, you can get them vertical or right angle, and that's it. Those are the two options. But I contacted the connector factory that we use, because we buy like thousands and thousands of these connectors, like tens of thousands. I asked them, hey, could you make a version that's 45 degrees? And they actually said they would try to manufacture a sample for me. So like, we'll see if we're able to get it. So let's go to my computer and I can show what I sent. So sometimes you just gotta like get your MS Paint action on. So I just drew this, showing, you know, these are the dimensions of the header. This is a 5mm by 8.5mm socket, and then there's, you know, two wires that come out and they're bent, and then there's this plastic spacer. The spacer is required because this is what lets it sit flat against the PCB, which is indicated here in green, and then this is 30 degrees. So you can see very, very basic drawing, but that's actually good enough. So they sent this back, and this is what they offered. They said, okay, well, we can, hold on, let me see if I can zoom in. You know, this is what it's going to look like, and it's flipped. So that's why it's like, it's not 150 degrees. It's like, it's negative. In your mind, if you rotate it, it's actually the same exact connector. And then this will be a 30-degree angle. And then they said they'd also try to make me a 45-degree angle one as well. And then I could try it out. We could just hand solder it and see, you know, if it works well, if it gives me the angle, if it's mechanically strong. I think it should work out. I think it'd be kind of cool. One thing to note is you're like, oh, why is there this like extra gap here? And this is necessary so that the PCB doesn't bump into, if there's any extra PCB, it doesn't bump into the thing it's plugging into. If you rotate this and think about the plane, it's like you want to have a little bit of space here so that this doesn't intersect with the Pi 400. This is just confusing because it's, maybe I'll rotate it like, yeah, so this is what I drew over here, and this is what they're giving me. So the PCB comes here, and I want to make sure that I have a little bit of space here so that it doesn't collide with the back of the Pi 400. So, will that work out? I don't know. We'll find out though. So let's prototype number one.
Yeah, the question was, could they use flexible PCB with stiffeners?
No. I don't know what you're asking, but the answer is no. Okay, let's go back to the overhead. Next up, I'm noticing like all the like sensor companies that make sensors are like doing revisions right now, or at least I'm seeing a bunch from like Sensirion and others. This is an HTU-31D, which is an upgrade we have in the shop. It's the, I don't remember who makes it. HTU. It's the HTU-21D. And who makes the HTU-21D? I don't remember.
Just a follow-up, yeah. In the chat, someone mentioned the same thing. So I was sketching out some stuff too, a two-piece PCB with a ribbon connector, like a laptop and a display. That would blow the price point.
Yeah, I mean, like anytime you have like, you know, connectors or flex, you can do it, but suddenly it gets very, like, how are you going to like set the angle, right? Like, or you could just get this connector.
Yeah.
The connector just does it for you. Okay, so this is HTU-21D. This is a TE sensor. The the 21D is what we stock now. The 31D is the new version, and it has much better performance. It has, I think, like under 2% humidity accuracy. And yes, I'm noticing like all these companies that make humidity and temperature and barometric pressure sensors all kind of revised their sensors all in the last 3 months. And I don't know if there were some deadlines, some patent expired, competition, whatever. But either way, I'm going to get some samples of the new HTU-31D, and I'll try it out. It's a nice QWERTZ sensor, and I think it's even like pin compatible with the old version, which I really like, because it means even though I had to change around the routing, I think the pins changed, but the stencil is the same and the PCB overall is the same. So that's kind of a nice design. We also got that SCD-30. This is a true CO2 sensor from Sensirion. And they are coming out with an SCD-40, which I'm excited to get my mitts on. Hopefully the SCD-40 will be available soon. It's still like not publicly available. I see it like a press release for it, but then no more info. So this is the sensor module, and then the sensor module gets soldered on to the board, which has a little carrier, and then, you know, I've got it like connected up to my Cutie Pie for development. But it's a true CO2 sensor. So this is like a really complicated sensor module. These things are not cheap. They're about $60. But, you know, if you want true CO2 measurement, this will do the job. Other sensors, they don't do a true carbon dioxide calculation. They just kind of give you like effective carbon dioxide, which isn't the same thing. This will give you the real deal, which is quite nice. And then this is what the board looks like. So we'll have to hand solder the connector on, like the header on this way. But it's not too bad. It's only a couple pins. And then all the level shifting kind of sits underneath. There's a little bit of gap space to make this nice compact board. So this was the only prototype we actually got to put together so far. Okay, and then next up, a couple weeks ago we started working on this Coral TPU, which is a machine learning accelerator. So we made this very basic breakout. I think this was like during Thanksgiving. I think we did this a few weeks ago, and then I just sort of wired it up to a basic 3.3 volt regulator and micro USB connector, and it came up under USB, like it enumerated. And so that made me think, like, okay, great, I got the pinout was correct, which is, you know, the first thing you want to do. And then I wanted to combine this all into a board, and then when I started doing that, it kind of ended up into like a stick format, and I decided, you know, why not just put a USB type A on the end, like this, so that once it's soldered, you know, this can plug right into a USB port. It's a little hack that we do on some devices. We also sometimes have a bare plug connector. So if you can go to my computer, I'll show what we sometimes do and people do. So there's, you know, if you're just plugging something into a normal USB A jack, you can do this little hack where if you use a thicker, like a 2mm thick PCB, you put the gold, you know, gold plating of course is best because it's a little bit more durable, and then you can just plug it right into the port, and it actually works kind of okay. Only thing I don't like to use this for is anything that enumerates over USB. I think if it has to maintain a USB connection, like because you've connected it, you know, you have some data transfer, I don't prefer this connector because it can be a little jiggly. It's very easy to pull out. What I do like it for in this case is, this is just a battery charger. There's actually no connection even to the data lines. It's just power. So if it gets jiggled, it doesn't matter because it's not like there's no established communication that you're going to, you know, completely lose and disconnect. So I only really recommend this style of USB connector when it's power only. Some people disagree with me and they say, oh, it's fine. I know it's cheaper, but I just personally, gives me the squiggles. So that's that. But we've done this technique of having a little USB stick before. So this is our USB sniffer, which has the Nordic sniffing software on this NR51 module,
USB to serial converter, and like a little switch. And then this USB A plug plugs right into a computer, and it's nice and solid. Makes a really nice, good connection. It has a little bit of indent, so it kind of snaps in. And it's like a very short connection. Like one thing you definitely don't have to worry about is like, oh God, my USB data lines are just like so long, and like I'm, or my power lines are so long, and I'm going to get power droop, because for the Coral design, it can spike up to 2-3 amps of current. I want to make sure that it's as close to the USB motherboard as possible. You don't want to be too far from that power source, because you get a 2 meter long cable, you draw 2 amps over it, and you're easily going to drop, half a volt, no problem. USB cables are not, unless you're paying for one that has high thickness, low gauge wire, you're going to get something that's cheap. You're going to have a lot of voltage drop. This reduces that issue.
right? If you have a connector like this, people are pretty much just going to plug it right into the motherboard of their computer. They're not going to, or into the hub. They're not going to like get a USB extension cord. That's actually kind of a rare connector. So, yeah, okay, so let's go back to the overhead. Yeah, so that's why I picked this connector, and then what's nice about this pinout is actually just by coincidence, the power line is up top, comes in, goes through this like buck converter here. I can like zoom in a little bit so people can see the. Goes through this buck converter. You see I have a nice big ground plane. Sorry, this is the ground plane. Where's the power plane? I'm trying to see it. Sorry, this is the power plane. So the power comes in through the inductor, through here, and into this power section over here. And then this is the ground connection up top, and you can see I've got nice big ground plane, and on the back, the engineers who designed this were traumatized by me saying I'm going to do this on 2-layer board. But whatever, PCB trauma is kind of my calling card. So I just made a really big ground plane over here with a solid plane without thermals. And then these are the 2 data lines. I just kind of scooched them over this way. Is it the shortest path? No, but that's fine because in the end I have the benefit of a huge ground plane right underneath the chip and going right into the power pins of this module. So, it's something you have to think about a little bit when you're dealing with some chip that is drawing, 2 to 3 amps. Will it work? I don't know, but we'll find out. So hopefully I'll put this together this week, and then next weekend I'll be able to demo it. I didn't, for the breadboard version, I didn't want to actually run any computational activity on it because the power supply was really small, and I didn't want to risk it was like if it enumerates over USB, I know it's working. I wanted to wait till I got a good power supply going, and then I could actually start doing some TensorFlow Lite with this coprocessor to see how good it is compared to having no coprocessor on something like a Raspberry Pi 4.
All right, a couple questions. First one, I'll go in order of what's on your screen. Will the Google Coral libraries recognize USB device, or will we run a software shim of some kind?
It's apparently built into TensorFlow Lite. So if you're running TensorFlow Lite and it has this in it, I think there's probably some call that you say like use the coprocessor. The chip is from Google, TensorFlow is from Google, so I have high confidence that there isn't a lot of nonsense that you have to do to make them work together.
Okay, and then if you can go back to your computer with that drawing of the connector.
Yeah, hold on. I have to close like every window known to man. Hold on. Where is that image? Okay, so this image.
Yeah. So the question was the angle where there was space between the angle and connector and the PCB one, so that could be one part, and some space between the connector and PCB then.
I don't understand. This is the angle, and there's a little bit of spacing here just so this PCB doesn't bump into the body of the Pi 4.
Could the angle one be covered or have it be spaced?
Sorry, don't understand what you're saying.
Yeah.
You need to have a spacer here to help it sit flat against the PCB. So this is like a mechanical stop. Otherwise, this could end up sliding. The PCB slides back and forth. So you want to have the connector itself, then the angle, and then the spacer to give you that mechanical stability against the PCB so when you select a solder it doesn't shift around.
Okay, well that's it for now. You want to
Okay, so
great searching?
That's right. So having picked this USB connector, this Type A, I thought, hey, we haven't covered USB Type A connectors on the Great Search, and these are very common. So let's get to it and
all right, let's get to the Great Search.
Where in the world is that part I need? The Great Search with Digi-Key.
Every single week, LADYADA, Adafruit, and Digi-Key brings you the Great Search. It's LADYADA using all of our engineering capacity, capability, and ability, and more to use the Digi-Key search engine on Digi-Key to find the part she's looking for, and she shows you how to do it.
That's right.
So what's
And-
this week?
All right, so this week I am making my Coral TPU USB stick, and I want it to plug right into a motherboard so I can get like that sweet USB current without having a cable in between. Also, it's nice and compact. I just like to plug in. And I want to show a couple different USB Type A connectors. USB A connectors, like we did DE9s, I think, last week or the week before, which I called DB9s incorrectly. There's so many weird variations of USB connectors. It's really good to know about them and page through them because there's some standard ones, but there's a lot of variations, a lot of variability in the market that could help solve a problem. Like while I was prepping for this great search, I found some connectors. I'm like, I didn't even know this was available. That's pretty cool. So let's go to my computer and we'll show what we're doing. So I want a connector that's basically this one, which I've used in a couple designs. It's a USB Type A plug, so it plugs right into a computer. If you have a Mac, modern Mac, you probably have USB Type C. We'll maybe in the future do USB-C type plugs. But for now, I really like these USB-A plugs. They're extremely common. They're, it's a very like USB key, USB disk drive, self-explanatory usage. And you don't need a cable. You just plug right in. So one thing to note, of course, is this is for USB 2 only. The device I'm using is USB 2 only. There's data plus, data minus, ground, and power. So it's different if you want to have. There are versions for USB Type 3, USB 3.0 Type A, but we're going to be looking for a Type A USB 2.0. So many versions of USB. Okay, so on to Digi-Key, and then we're going to just type in USB connector because that's a good place to start. Why did I type in Type A? Because it's like whenever I have something where it's going to be very quick to select it, I actually usually just leave it off and I go straight to the category and then I filter within the category. So there's a lot of there's weird categories and adapters and connectors. Again, USB is kind of like a catch-all for so many different power and data transmission schemes. Whenever you look for USB stuff, there's going to be a lot of categories available, like a speaker that's USB. Okay, so we're going to start with, of course, only active because we're speccing for a design and something that's normally stocking. And then USB, it's interesting, USB, DVI, and HDMI connectors are all in the same category. And I kind of understand why. It's like this plug and socket style, cable connector. However, that means that we want to quickly pare down what we want from within this category. So what's nice is that this is, nicely divided. There's micro, A, mini, USB A, B, and C. So let's just at least pick out the A's so we can minimize what we're looking at. And I definitely recommend, Digi-Key used to have like a paper catalog. I don't even think it exists anymore. I think they've stopped sending it because it was just so, they couldn't keep up. But one of the nice things about the catalog is you could page through it and look at the photos and get an idea of like did you know that such a thing existed, this like combo A-C connector? I didn't, not until I just moused over it. So sometimes when you go into a category, sometimes I go straight to the product I want, but sometimes I like to go to the category and then just kind of like mosey around. Like we can't do that in stores right now. If you go to a store, like they're like, get in, get out, because there's a line outside for this cheese. But online, you can look at the images as long as you want. So, for example, this kind of cool 3.0 like launch mount connector is cool, and then there's stacked style. This is kind of neat. USB A on top, C on the bottom. This is like a USB mullet, I guess. I don't know. Twofer. This is like a nice, strong, like sealed jack. This is neat. This is a USB socket that goes up, and this is the 3.0 version. There's like all sorts of like right angle, non-right angle. But anyways, you want the plug. So let's go down here and then pick plug because we want something that plugs into a computer. And you'll see that really quickly reduces the number of entries. Next up, we want it to be, this is actually something that's interesting. So there's this panel mount through hole, surface mount right angle, surface mount right angle through hole, and through hole right angle. And you're like, okay, like why does it say surface mount and through hole and then surface mount through hole? So let's select all three and I'll show you. That's something to watch out for. Another thing is because I'm only using USB 2.0, I'm not using USB 3, I'm going to pick number of contacts 4 because again, I don't need all the other super speed contacts. I just need power, ground, data plus, data minus. And I don't want any sort of stacked thing. So this is going to give me only the USB 2.0. So when you're getting these connectors, and this is something that I've learned very quickly, is if you want to go with the surface mount and through hole headers I was talking about earlier in Desk of LADYADA, surface mount headers and surface mount connectors are easier to manufacture in the process because you can pick and place them. And so whether you're, no matter what quantity you're manufacturing, or even if you're doing small, large, whatever, to reduce your manufacturing complexity and cost, not total BOM cost, just the manufacturing process cost, you want to pick surface mount usually. If you have surface mount components and you have surface mount connectors, they all can go through one process at one time and it's like kind of easier. But if you are looking at your total BOM cost and manufacturing cost, through-hole connectors are going to usually be cheaper than surface mount. And if you have a through-hole process, then the mechanical strength will be higher with through-hole components. That said, there's this like mix and match type connector. So this connector is through-hole. So you see that there's like the 4 legs coming down. Those are through-hole because they go into the PCB. And then you see that there's like the mechanical connector side pieces. And those are through-hole. So this has to be selective soldered. You're not going to be able to surface mount place this. However, there's also, let's look at the surface mount only. So surface mount right angle, there's a couple options. This is actually not, this is actually a true surface mount. Hold on. Maybe because I only picked, let me try the surface mount through hole. See if I can get him to come up. I actually think for the type A, they don't have it. But, for example, this connector, and let's go to the 360 so I can show you, because the angle is always tough. So this one is combo. This one is, it has surface mount pads, right? They go straight out, and then they have this through-hole mechanical connection. And for this connector, you would probably, I don't think they even make a version that's pure surface mount that has the mechanical connections splayed out. However, you'll see that for USB type A, micro B, and mini A, mini B, micro B, and you'll see it for the socket version of the type A connector, but not the plug version. And for those, you'll need like really big pads for the mechanical connection. And there's usually 4 of them. And it's kind of iffy. Like, I definitely seen more connector failures due to surface mount USB connectors than any other connector. Like, they get really wrenched. Like, people are like plugging it and twisting it. And so if you're going to do a surface mount connector for your USB, try to at least get it be 50-50, like have the mechanical tabs be through hole and the pads be surface mount. And you can process this in a surface mount pick and place line. You just put like a lot of solder around the connector. So I'll actually show that on the overhead with my micro B. So let's go to the overhead because I have this handy anyways. So on this micro B connector, you can see that the pads, the 5 pads on the center there, are surface mount. But then the mechanical connection, these 4 pads, I make 4 really large through-hole pads, and you see they're like mechanically quite large. And then when they're pasted over in the silkscreen, the paste deposition process, a lot of paste gets put on them so that when they get soldered through the oven, you see you get a lot of paste and you get a lot of mechanical strength. So these are not selector soldered or hand soldered. There's just so much paste left from when it was silk screened on that it creates a very strong mechanical connection. And Phil is my mechanical tester.
Yeah.
I give him the connector and I give him a cable and I say, try as hard as you can to break it off. And he eventually does, but usually the whole PCB delaminates, which is what you want. So it's just something to watch for if you do surface mount instead of surface mount through hole connectors. If you're doing surface mount, you have to have some enclosure or other mechanical thing that's going to hold the connector flat against the PCB, or it'll just wrench right off. That happens all the time. And then the product is destroyed because you can't rework a ripped off SMT connector like that. So that said, all right, so sorry, we got distracted there. So that said, in this particular case, I'm not going with a surface mount USB type A. I might change my mind, but for right now, I'm going to probably stick to the through hole, like both parts are through hole. So I'm going to select just that one. And there's not a lot of options here, but there are a few. So you can see they basically all have this style where there's this, tube pads connecting. And then what's interesting is actually there's this notch that holds up against the PCB that gives it a little bit more mechanical strength as well. So that's another thing where, you can't pick and place this particular connector. You really do have to hand place it and then selective solder it. But there's a couple options. Another thing I do recommend watching out for with USB connectors is there's many sort of obviously it's standardized for the plug, and then the contacts and the mechanical connection are usually very close, but you'd be surprised. What looks to be identical, like these all look identical, the location of that mounting tab and its size, it can be slightly different between different connectors. And so when you think of these as like, oh, I need to make sure I have some alternates in case the one I'm using is out of stock, really make sure you get samples of all the ones that you think are alternates and like mechanically try them in a board. Because many times I have, received like, oh, this is an alternate, or it'll be suggested, oh, you can use this connector instead of that one. Or somebody will, we once worked on a board where somebody used a connector and it wasn't available at Digi-Key, and they just looked at the photo and were like, oh, this looks like the closest one. And we bought 1,000 of them, and it turned out that the legs that were the mechanical strength, connection were just like 1 millimeter farther apart than they should have been. And so we had to delay all our manufacturing until we found the matching part. So it's definitely something that has bit me a couple times. Also look at the mounting nubs. Sometimes there's little bumps on the bottom to help locate the connector. Sometimes they're there, sometimes they're not. Sometimes they're a certain distance apart, sometimes they're closer or farther. So these things, even if the connector itself is standardized, those things will vary from part number to part number. That said, thankfully, I've used this part, so I have a version available, and you can see there's a couple options. Like this one from CNC Tech has 25,000 available. The connector I ended up using, because it's got a low price and it worked quite well, and it has this nice goth plastic, is this one, the CUI Devices up to AH1TH. I like CUI. And I do recommend when you get connectors, what I like is this 360 view. Can really save you a lot of effort and confusion looking at, for example, you can see here, hold on, maybe, you can see here, there are these two mounting nubs, just barely, maybe I can zoom in, there you go. So you see that there's these two mounting nubs, so watch out for those. Make sure your design accounts for these mounting nubs. They add mechanical stability, they're very handy, but if they don't match the holes in your PCB, they're not going to fit, they're not going to work, and your whole line is going to be delayed. Very sad. So only thing to watch for is that. Make sure you download the data sheet and check your PCB layout package against all nubs, mounting holes, cutouts, etc. So that is my tips and tricks for USB-A connectors.
That's a great search this week.
Yes.
Where in the world is that part I need? The great search with Digi-Key.
All right.
Okay.
So, one question,
Questions.
and then maybe your request.
Yeah.
Can you run MicroPython on the Adafruit Feather Huzzah ESP8266 board?
You can go for it. MicroPython is available for the ESP8266. We, even have tutorials for it. We don't support it because we've moved on to CircuitPython, and now with the ESP32 S2, which is kind of like almost the same price as the 8266, and like the USB and the extra memory, we like it more. But you can use 8266 Feather with MicroPython. Just go to micropython.org and download their latest firmware. Their Kickstarter even used the Huzzah as one of their dev board platforms.
My suggestion, December 13th, 2020, is to get an ESP32 S2 because you can do anything with it.
Yeah, you do get things like better TLS SSL security. You get all these certificates built in. It's much faster. There's more memory. If you have existing hardware, it's a great way to upcycle it. But if you're kind of just coming up with a new project, the ESP8266 is well loved, but it's time for it to rest and move on to bigger and better platforms.
Yeah, if you asked me not too long ago, I'd say stick with that. But if you're just starting to get going with something, don't limit yourself. ESP32 S2.
That's where it's at.
Okay, and then there's some requests, new video segment, breaking boards with fill, and or will it blend, will it break, breaking bad boards.
We can definitely show the stress testing of the USB. I mean, Phil, you've seen it. I give you a board and I'm like, especially with a new USB connector. I think we did that with the USB-C on the Cutie Pie. I gave you a Cutie Pie and I gave you a USB-C cable. Yeah. And I said, break it, and you wrenched it apart.
Yeah.
You were like, this is pretty hard, but you did eventually get it.
Yeah, what we want to know is if a customer is going to break it, what did they have to do to get there?
And I'll say, we don't have it come up. It's very, very, very rare. It's usually like...
For 10 plus years, I'm not on every customer support email, but I used to be. This is one of the things that we're very proud of. That does not happen.
Doesn't happen.
Yeah, okay.
So I like that. There's actually a name for it. It's like through a whole place, or like, I don't know, paste in place. There's some name for these, but I call them like mix and match. They're like 50-50, surface mounted through hole.
Makes sense. Okay, that's our show for the Sunday this week.
Thank you, everybody.
Thank you so much for joining us and spending your time with us. We very much appreciate it. Thank you for all the orders. It's been keeping us going. Continue to have a good and safe holiday. Folks, we've got a ways to go with this pandemic. Please wear a mask, keep your distance, sanitize, all those good things. We very much want to see everyone in 2021. We just have to go through some shit to get there. So
we're so close.
Yeah, so please hold tight, hang in there, and we'll see you throughout the week in all these shows and more.
Okay, don't forget, 20% off your orders when you your next order when you secure your account. If you haven't done that yet, so do 2-factor. And we have a couple of AdaBox slots still available that you can open.
Adabox.com.
If you haven't signed up, you can slip right in right before we close. We're going to close in the next day or two, so this is your last chance.
All right, thanks everybody.
For the holidays. All right, thanks everybody.